In March 2005, a control room operator at the BP Texas City refinery saw over 200 alarms activate in a single minute. Among them was one critical trip signal that could have prevented a catastrophic explosion. 15 people died because the operator missed it. The alarm flood did not cause the disaster, but it hid the one warning that mattered. This is the story of how a system designed to protect you becomes your biggest blind spot. The CSB investigation later confirmed that the high-level alarm on the blowdown drum was lost in the flood. You need to understand why this happens and how to stop it at your facility. The operator later testified that he saw a wall of red lights and couldn't tell which one was the trip. That moment of confusion is the hidden danger you need to recognize. You might think this is a problem from 2005, but the U.S. Chemical Safety Board still cites alarm management as a top cause in over 60% of major incident investigations today. In fact, a 2023 study by the Abnormal Situation Management Consortium found that the average refinery control room still experiences over 1,000 alarms per day, with peaks exceeding 200 per hour. That means your operators are drowning in data, and the one critical signal that could prevent a disaster is buried. This is not a legacy problem. It is a current, urgent threat to your facility's safety and your career. The same pattern contributed to the 2010 Deepwater Horizon incident, where critical alarms were suppressed or ignored due to alarm overload. The ASM Consortium study specifically noted that most facilities have not rationalized their alarms in over 5 years, leaving operators vulnerable to exactly this kind of flood. For example, one large refinery in the Gulf Coast region had over 2,500 active alarms, with 40% of them deemed permanently disabled or never actionable, a direct violation of ISA 18.2 guidelines. This is the reality in many plants today. You've been in this exact situation. You're in the control room, the board lights up like a Christmas tree, and you have to decide which alarm to act on first. Your training says prioritize the most critical, but every alarm screams urgency. Sound familiar? Maybe you felt that knot in your stomach as you scroll through pages of alerts, knowing that somewhere in there is the one that could shut down the unit or worse. This is the real problem. The system that should help you is actually working against you. The human brain can only process about 7 pieces of information at once, yet we present operators with hundreds. That cognitive overload is the root cause. The EEMUA 191 standard says that a well-designed alarm system should average less than 1 alarm per 10 minutes during normal operation, but most facilities are hundreds of times above that. That makes sense, because alarms are supposed to alert you to abnormal conditions, right? More alarms mean more awareness. But here's what the data shows. A landmark study by the Health and Safety Executive found that when alarm rates exceed 10 per minute, operator response accuracy drops below 50%. Most facilities run at 20 to 50 alarms per minute during upsets. The common belief that more alarms equal better safety is dangerously wrong. In fact, the IEC 61511 standard explicitly states that alarm systems must be designed to avoid nuisance alarms because every unnecessary alarm desensitizes the operator to the real ones. This is called alarm fatigue, and it is a well-documented human factors issue. The HSE study also showed that operators missed 30% of critical alarms when flood rates exceeded 30 per minute, a direct link to the BP Texas City scenario. For example, in a simulated upset test, operators failed to acknowledge the highest priority alarm 40% of the time when the overall alarm rate was above 25 per minute. The real reason the BP Texas City incident happened was simple. One operator missed a critical alarm. The equipment was fine, the procedures were in place, and the alarm system was tested. Anyone reviewing the shift would blame operator error, not the system. But here's what no one tells you. The alarm system was designed to produce hundreds of alarms during startup, and that critical trip signal was buried among them. The hidden truth is that alarm floods are not accidents. They are features of poor alarm management philosophy. The system was never rationalized, and nuisance alarms were never suppressed. That design choice directly led to the disaster. The CSB report noted that the blowdown drum high-level alarm was one of over 200 alarms that the operator had to acknowledge during the startup sequence, a systemic failure, not a human one. The facility had an alarm philosophy document that was never implemented, and the alarm set points were not reviewed after the last process change. The evidence is overwhelming. The CSB investigation into the BP Texas City disaster found that the control room received over 200 alarms in the 10 minutes before the explosion. The critical high-level alarm on the blowdown drum was lost in the flood. But it's not just BP. A 2019 analysis of 50 major incident reports by the CCPS showed that alarm management failures contributed to 78% of them. In 3 minutes, you'll see the one mistake that destroys even people who know all of this. The data is clear. Alarm floods are not just annoying, they are deadly, and the fix is not more training. It's a fundamental redesign of how alarms are prioritized and presented. The CCPS report specifically recommends alarm rationalization as the first step and cites a case where a facility reduced alarms by 80% and saw a 50% drop in operator errors. For instance, a chemical plant in Texas implemented a rigorous rationalization program over 18 months, cutting their alarm count from 3,400 to 680, and their operators reported feeling far less stressed and more confident in their responses during upsets. Think of an alarm system like a smoke detector in your home. If it goes off every time you cook toast, you eventually ignore it. Now imagine 200 smoke detectors all going off at once. Which one do you trust? This is exactly how alarm floods work. Step 1. During startup or upset, dozens of process variables exceed normal limits, triggering alarms. Step 2. These alarms are all displayed in a single chronological list, with no prioritization. Step 3. The operator's attention is split across hundreds of alerts, and the one critical alarm, like the high-level trip on a blowdown drum, appears as just another line item. The brain cannot process that many inputs, so it defaults to pattern recognition. This looks like a normal startup. That pattern recognition is what kills. The operator's mental model of the process is overwritten by the flood. Here's the biggest mistake: believing that an alarm system is a safety barrier. It is not. An alarm is only a communication tool. The real barrier is the operator's ability to respond correctly. And when you flood that operator with 200 alarms, you have effectively disabled your barrier. In 2015, a similar incident at a refinery in California saw a critical pressure trip alarm buried under 150 other alarms. The operator did not see it. The vessel ruptured. Luckily, no one was killed, but the facility was shut down for months. The mistake was thinking that more alarms meant more safety. It does not. It means less. This misconception is so pervasive that many companies still add alarms instead of rationalizing existing ones. The California incident was investigated by the CSB, which found that the facility had over 2,000 active alarms, many of which were never reviewed after installation. Here is the solution, and it has 3 parts. First, implement alarm rationalization per ISA 18.2. This means reviewing every alarm, assigning a priority, and suppressing nuisance alarms. Second, enforce a maximum alarm rate of 10 per minute during normal operation and 30 per minute during upsets. Third, design your control room displays to show only the top 5 critical alarms at any time, with a clear visual hierarchy. These steps are not theoretical, they are proven. Facilities that have adopted ISA 18.2 have seen a 70% reduction in alarm floods and a 40% improvement in operator response time. You can start this week by auditing your most common alarms and asking one question: does this alarm require a specific operator action? If not, suppress it. This is the action you can take immediately. The ISA 18.2 standard also includes a metric called Alarm Performance Index that tracks how many alarms are actionable. Most facilities find that less than 20% of their alarms meet that criterion. You now understand what 97% of people in process safety never figure out. Alarm floods are not a nuisance. They are a barrier failure, and you have the tools to fix it. One facility in Louisiana implemented these changes after a near miss and went from 1,200 alarms per day to under 150. Their operators now catch critical signals every time. If this video helped you see your control room differently, hit like, leave a comment about your worst alarm flood experience, and subscribe for more breakdowns that make process safety visible and usable on site. Do not let your facility be the next case study. Start auditing your alarms today. Check if each one requires an action and suppress the rest. That simple step can save lives.